Hey, what's up? I'm Jason, and I've been developing games for about 20 years, but when I started with Unity, I still got confused about how to move things. There were so many different ways that I could move objects around and different systems that I could use. I really didn't know which one was right for me and which one fit my scenario. So in this video, I'm going to teach you everything that you need to know about moving objects in Unity. We'll talk about things like basic movement, how to get around the scene view, scene editor, and move objects in there. We'll talk about moving them through their transform position. I'll teach you how to use rigid bodies to bounce things around and character controllers to move characters. We'll go into navigation and animation and a whole lot more. If you're new to Unity, this video should be perfect for you. We're going to start off assuming that you really don't know a whole lot about it and kind of at the beginning, but if you're a more advanced user, hold on for just a moment because there is a really cool trick that I just learned a couple weeks ago that most experts don't know about, and I think it might save you a lot of time and just be cool to learn and probably a lot of fun. Before we start though, if you have any questions about this video or just about movement in Unity in general, drop them down below and I'll get back to you as quick as I can and try to help you along the way. Also, if you think of anything that I missed, some movement system or movement thing that I probably should have noted, or that you're just kind of more curious about, drop a comment too. It's helpful, it kind of gets the discussion going, and YouTube loves it as well. And speaking of that, please don't forget to hit that like button for me and YouTube. It makes us both happy. Before we talk about how to control an object's movement with code, let's talk about how to control it in the editor and in the scene view. We're going to create a new cube here. So I'll go to Game Object, 3D Object, and create a cube. And notice that when I created it, it just kind of popped right up on top of me. The first thing, and the thing that I use most often in Unity for setting positions, is right-clicking on the transform and hitting reset. That sets all of the position, rotation, and scale values back down to their default. So 0, 0, and 1s. Of course, that's down below my ground cube that I've already pre-placed here, so I can use it with the move tool. The move tool lets me move up, down, forward, and back. And I can switch to the move tool right here. This is the rotate tool, and I click over here to the move tool. So if you're seeing a different tool, different little indicators here, you can go back to the move tool like that, or hit W. W is the shortcut for switching to that move tool. So once I'm in the move tool, I can again move it around. I can grab one of these arrows here or these side pieces and just drag it and put it into position. I can also move this with the transform component here. So I can take this X value and just type in a different value. It's at 1.9. I could set this to 5 and move it to the 5 position on X in my world. I can also grab this X value and just slide it back and forth to move it. I can do the same with Y, which is going to move me up and down, and Z, which will move me backwards and forwards. Now, another really useful feature for moving things is the grid snapping. If I hold down the control key or command and drag, notice that the value here is going by 0.25. So it gives me nice, easy snapping if I want to snap objects together. This can be useful if I say have 2 cubes. So if I duplicate this with Control D and drag it out here and I want them to line up perfectly, just held Control the whole time and it got them lined up perfectly. One's at 5.5, one's at 6.5, and they're 1 meter wide, so they line up great. The last thing, and this is the really cool trick that I wanted to share that I just learned about myself, is this neat little Control Shift option. So if I hold down Control Shift, I can grab this box and it'll actually snap to the side of the objects that I'm touching. So it'll snap the colliders together. Now, moving objects in the scene is great and all, but really we want to move our objects in code. We want our player to be able to control things, and the easiest way to do that is to control this transforms position from our code, and that's what we'll start off with. So here we've opened up a scene called box moving with input, and I have a moving box and it has quite a few components on it. So let's take a quick peek at it. It's got a cube, mesh, and a mesh renderer. That's just the default from the cube, along with the box collider. If we make a 3D object that's cube, we get those. But then it has these 4 scripts on it. Only one of these scripts is enabled though, with this little checkbox. All of the rest of them are off, and we're going to cycle through these in different parts as we talk about different types of transform-based movement for our cube. The first one is called Move Transform Position with Input. Let's open up the script and see what that looks like. So here we have our first class, our Move Transform Position with Input class that has the single update method that gets called every frame by Unity automatically. Now here we're doing a couple of different things. The first thing I want to look at though is actually not up at the beginning. It's right here on line 19. And I have a check that says if input.getKeyDown for the key space. So if I've pressed space this frame, then we set the transform position to a new vector 3. We set it to 0 on the X, 5 on the Y, or 0.5 on the Y, and 0 on the Z. And if you're not sure what those are, if I hit the backspace and just hit the comma again, you see the little pop-up appear. So that's the value that I'm going to set this to if I hit space. I'm going to just save this real quick with Control S, go back into Unity, and I'm going to move this cube before I hit play, just get it off into some random position. In fact, I'm going to hold the Control Shift and do that little trick and make it maybe snap to the side here. Let's make it snap on top. Then I'll hit play, and then I'm going to hit space and watch what happens. It resets back to the default position, that 0.5 and 0, or not really the default, but the position that I have hard coded. Let's try moving around with those arrows. I'm sure you saw the arrow code. So I hit up arrow and it goes forward, down arrow and it goes back, left and it goes left, and right and it goes right. I'm going to stop playing and open up that code one more time and take a look at how that's accomplished. So on line 7, we check to see if the right arrow was pushed down or pressed, and if it was, we just add vector 3.right to the position. And if I look here, I wish I could just point right at my screen, but if you see the vector 3, or the shorthand for writing vector 3 1, 0, 0, vector 3.right just means a 1 for the X and 0 for the other. So we're adding 1 to the X value. Here it's a -1 for the X value, a 1 for the Z value, and a -1 for the Z value. That's all we need to do to move very basic snap-based movement. Now this is something that we would use in more of a grid-based or tile-based game, or something of that nature, where objects are moving along into these set slots or set positions. That's what you would use this for. But you might want to limit or lock that movement too. So let's take a look at an example of how we could do that, but maybe constrain this movement just a little bit. Now we're back in the scene. I'm going to expand out my inspector a little bit, and then we're going to uncheck the move transform position with input, and I'm going to check the move transform position with input limit movement. This is the same script, but with some movement limitation set up. So now I'll hit space. I'm going to, or hit play and then hit space, get reset, and then I'm going to try moving around. So I'll go forward, and when I get to this point, I keep hitting forward and nothing happens. I go left, and it stops me there, go right and it stops me here, and I come back and it stops me. So I'm limited in my movement, but you may have also noticed that we're going through these boxes. And when we get to rigid body physics and rigid body movement, you'll see how we'll stop that. But for now, let's look at how we've limited the movement based on its actual position. And if you look at the position, you might notice that it's going to -5 here, 5, and all the way over to +5. Let's expand out the script and open it up. Here, our move transform position with input limit movement script, very long name, does a lot of the same things that our previous move transform position with input script did, except that we have this extra check. In fact, it's the exact same code, but we have these double ampersands and this transform.position.x less than 5. So what's going on here? Really, we're checking to see if they've pressed the right arrow and that the position is less than a +5, so that we can't move right if our position has reached 5. If we get to 5 or greater, there's no more moving right. We're stuck, we can't do that. We'll have to move left first. And if we look at our left check, we check to see that the position.x is greater than -5, because we can't go left anymore, which is going negative or beyond 0. The next two parts are kind of the same. We just check the Z position for up arrow and the Z position for down arrow. Again, with a 5, and here I went with a -1, so we couldn't pull the box in too close to the camera. Nothing too exciting, but I wanted to show what this looks like and how we add in some extra, very simple limiting. We don't have to necessarily have box colliders or things preventing the movement. We can just write in some simple code if this supports our game and this is what our systems really need. Now, before I jump ahead, I want to really quickly show how I would rewrite this in a slightly easier to read version. And that is in our movement cleaned script. So here you'll see that all I've done is taken these if statements and converted them into properties that are named for what they do, so, or what they're checking. So here I say, if we should move right, then add the right movement. If we should move left, add the left movement. If we should move forward and should move back. It's just, again, to make it a little bit easier to read and easier to understand as we're going through. You can imagine that as these conditions get more and more complex, it can get a little bit confusing to understand what it was and what it was that you're checking, and if that check is the correct check for the movement, and having to mentally map it. So I find that doing something like this, creating these little private properties using the expression body property method. The next movement type we'll talk about is one that I think most people really care about, the one that you're probably trying to use in your game, and that's moving around an object smoothly, more like this, where we have a cube that we can control and just have it move smoothly along and maybe control the speed. Crank up that speed and watch it fly along fast, or slow it way down and make it crawl. Let's try that. 0.5, and you can see it slowly moves along. So how is this accomplished? How do we do this? Let's take a look at the code. Here's our move transform position with input smoothly script, and you'll see that we have a serialized field that's a private floating point value called move speed, and it's defaulted to 2. That's controlling our speed, and you'll see how we use that on line 11 in just a moment. Next, I want to look at line 10, where we call input.getKey. Here, I want to note that getKey is very different from getKeyDown. GetKeyDown fires once when we press the button, and we use that for things that we want to bounce around or have step-based movement or single-time input reads. GetKey returns true every frame that we hold this arrow down. That's how we're getting the smooth movement. So every frame, this is going to be true as long as we're holding it, and we'll add the position, well, with this vector 3.right, but we don't just add vector 3.right. We multiply it by our move speed and by this magical time.delta time. And this is really kind of where all the magic comes from. Time.delta time is the amount of time in seconds since the last update was called, or since the last frame was called. So what this is going to do is smooth out this movement so that we move 2 meters once per second. This update will be called so many times per second, maybe it's 60 times a second, whatever that number of times a second is, over the period of 1 second, the delta time will have added up to 1. So imagine it was just 4 frames. Say we ran at 4 frames a second and each frame was at 0.25. We would do a quarter of it the first frame, a quarter of the movement the second frame, a quarter of it third, and a quarter of it the fourth frame. Eventually we would make it the full 2 meters. So this is actually our meters per second in movement speed. So all we do is multiply those and we get the value, and it moves nice and smoothly. Now let's talk about rotating, because our current setup really only allows us to move an object in this one world position, and if our camera adjusts, well, we don't have lined up movement anymore. So how do we do that? Well, let's disable this script, and I'm going to enable my move transform position with input smoothly and rotation. We'll start moving around, and here I'm using WASD to move, and Q allows me to rotate along with E. So I'll hit Q and then hit W, and check it out. Now I'm able to rotate and turn. Now let's see what it looked like on the previous one. If I go check this other box and I've already rotated and I hit my arrow keys, notice that I still move in world space. In fact, I can actually enable both of these because I've bound them to different keys. I can use my arrows to move in world space and my WASD to move in local space and rotate and control that. Very interesting movement. So let's check out how this script works and how we're able to do the rotation-based movement, because that's usually what we want. We usually don't want to just move in world space unless we have a fixed camera that's never changing. All right, let's go open this up. And our move transform position with input smoothly and rotation script has 2 serialized fields. We have a move speed for our movement in meters per second, and a turn speed for just how fast we're going to rotate. Here you'll see that we have a lot of the same code that we had in the previous section for our movement, but I've bound them to D, A, W, and S, or WASD. And our D key is going to move to the right, so we just take delta time times move speed, and here we don't use vector 3.right. This is the big difference. If we want to move local to our object or our transform and not world space, we can just use transform.right to do that instead of vector 3.right, which will give us the world space movement. The other thing that we need to note is there isn't a transform.left, but negative transform.right is the same as left. And then we get the same for forward. We have transform.forward and negative transform.forward to go backwards. The other part that's new here is the rotation. So Q is set to turn me to the left. So I call transform.rotate, and we pass in time.delta time and our turn speed, or we multiply this value times that. And then we use vector3.down because I want to rotate in the negative direction on the y-axis. And if I go into Unity and I just look at this, if I just drag this down, I can see the value going down means left and value going up means right. Good way to test if you're just kind of getting mixed up and not sure. You know, just go in, drag these values around and see what happens. Now we'll talk about rigid body movement. This is a very common type of movement used to control objects that need to respond to physics. Here I've set up a cube that we can move around using its rigid body component. I've added a rigid body to it, have not changed any of the default settings, and we've added this move with force script. It has a movement force value of 10, and you can kind of see how the object bounces around. Now let's look at our move with force class. It has a rigid body component that we are caching in the awake method. In our awake, it's just an expression body method because there's only one line, so it's only doing one thing. We say rigid body equals get component rigid body. So that's just going to get a reference to this rigid body component so that we can tell it to add force later. So in our awake, we do that. We also have this serialized field for our movement force, which is going to control how much force we add to the object as we hold the key down. Now this will need to be relative to the mass value set on the rigid body. As the mass goes up, we need more force to move the object around. The next thing we have is a fixed update method, and this is different from our update method. Generally, when we add force to a rigid body or a lot of physics objects or doing a lot of physics related things in general, we want to do them in the fixed update. Definitely adding force to a rigid body though we want to use in our fixed update step. The fixed update is very much like the update with a tiny little bit of difference. It's where all the physics work is actually done, and it has a special priority so that it can run at its own special frame rate and that we can have our physics be a lot more reliable and not fall apart when our frame rate falls apart. So we need to do this in fixed update. If we do it from update, it will give us some issues, and you'll notice them where we get 2 force calls in one frame, and suddenly one frame we get a little boost or a little extra stutter. In fact, if you change this code and you go from fixed update to update, you should be able to replicate and see that negative behavior, that problem where it starts bouncing around a little bit and it isn't as smooth. Now let's take a look at how it actually works. On line 13, we just check to see if the W key is being held down with input.getKey. So if we're holding W, it's true. And then if we are, we add force to the rigid body, giving it our movement force multiplier and vector3.forward. So this is going to move along that Z-axis. It's going to add to the Z-axis. And it's just going to make our object kind of push in that direction, which on our cube is kind of making that weird rolling action, which I think is kind of cool. Now let's look at how we can make a cube move around in a more natural fashion, more like a character. Have him maybe slide and bounce into walls and stop. So to do that, we have a move with force use transform rotation script. I'm going to hit play and show you what that does if we only turn this script on. So I hit play and I roll forward. It's not doing what I wanted, and I can roll to the left. Can't go left anymore. Now if I hit forward, I go a different direction. This is all because the forward direction of my object is getting out of whack. So let's take a look at that. If I look at my blue value right there, forward is actually pushing down, and I believe right is going to push that way. So I hold right and I go that way. Now forward is pushing left. So if I hold forward, it's actually going to roll to my left. Not the behavior that our player would want. Really, really confusing. So how do we fix this? Well, if I reset this transform position and I check the freeze rotation boxes here, suddenly I can move a little bit. If I hold the 2 together, I can move, but I'm no longer getting that rolling behavior. So why can't I move anymore? It's because there's not enough force to actually give me a slide. So I'm going to crank this force up to 20. And now I can kind of slide around. So you can see I'm able to slide. I still can't quite turn. So how do I add in some turning? I'm going to add in another script, and then we're going to go take a look at both of these scripts together. So we're going to add in this rotate with mouse script. Now, if I put my mouse over the game view, I can turn it, and I can hit W, and look, it moves in the forward direction. I just hit A there to go sideways, D to go left, go back with S, and W, and I can just kind of rotate all around and drive like a crazy man and bump into boxes and not go through them. So now I have some limited physics-based movement. Let's take a look at those scripts and see how they actually work. First, I want to look at the force use transform rotation one. Here we've got a public class, move with force use transform rotation, and we cache the rigid body in our awake method on line 9 so that we can use that later to add force, and we have our movement force variable that we can adjust the speed with. And remember, here we had to crank it up to 20 because when we're not rolling over, we actually need a little bit more force to get over the friction to be able to slide along the ground. In our fixed update, we check to see if the W key is held. If it is, then we add the force. Really nothing different here from our previous one except for using transform.forward. So just like in our transform position movement, if you saw that, we use the transform related vectors, our transform forward and our transform right. Here we use transform forward, transform right. And again, we use the negative values to give us back and left. In our rotate with mouse script, we have a turn speed, so we can adjust how fast our player can turn. And then we have an update method, which gets the axis value for mouse X, which is actually a float. Let's just spell that out. It's just a number, and it's going to be positive or negative, some small number. Then we call transform.rotate. We pass in the horizontal value, which is just that mouse X value. This is, again, how fast we've slid the mouse left or right, or how far we've slid it left or right. The turn speed, we multiply it by, and then vector3.up, because that's a 1 on the y-axis. So we're just rotating on the y-axis, and we're using world space to do that rotation. Now let's take a look at jumping. How would we implement a jump with this? Well, we can turn on our jump script, hit play, see what it looks like, and then go take a look at the code. So here I've got it. I can move around, and I can hit space and jump and kind of bounce around. Whoa, and now I just jumped kind of wildly. Now I'm going to turn off the rotate with mouse one. I'm going to go to move with force and see what that looks like with jump. So I got, oh, and turn off the freeze rotation options. So now I should be able to kind of like roll around and do a weird bouncy jump. And let's get the scene view and game view together so we can get a nice big view of what that looks like. And kind of jump around and do some interesting weird behavior. I'm not sure what use it is yet, but I think it could be fun. Let's take a look at the jump script and see how that ties in and how that works with these other two scripts. So if I expand it out, you'll see that we have a jump force set to 300. And I'll open the script up and we can take a look at the jump class. It has a rigid body that we cache and awake, very similar to a lot of the other scripts that we've had. And then it has a jump force with a value set to 300 and this Boolean value called should jump, which is either going to be true or false. It'll be false by default. And then I have a big note about why we have this should jump and why we have an update and a fixed update. Because you might think, well, in our update, we'll just read and see if they pressed the key, then we do a jump and we add some force in the up direction. Or maybe we'll read it in the fixed update. The problem is very well spelled out here, I hope, in the description or the comments that you can download this code and go look at yourself, is that it's possible for us to miss a space call. So it's possible that we hit space and the player doesn't actually jump if we put everything into our fixed update. So if we change this to say something like this, I'm going to copy it and paste it. If we didn't have this, I'm going to comment this out with Control-K, Control-C. If we had it just like this, it's possible that the user presses space, we run an update, get key down is already processed, and it's already returned true for that update. Then we run another frame. Fixed update hasn't run yet because fixed update doesn't necessarily run with every update frame. So we run another update and the user is still holding space. So get key would return true, but get key down no longer returns true. And then our fixed update calls and get key down is returning false, and we've missed that jump. So this is why we read our input in update and then we act on it in fixed update when it comes to these get key down type events. If it was just a get key, I'm going to hit Control-Z twice to undo that, by the way. But if it was just a get key check, so it wasn't a get key down and it was for every frame, it would be totally fine. That's why we can do that for our movement, but for our jumping, we don't want to do that, and we want to separate this out and really spell out the issue there. Now let's have a little fun and see what this all looks like when we change our object from a cube to a sphere. So I've got a rigid body based sphere / ball, and I'm going to turn it on and hit play. You're going to see a little bit of magic, and then we're going to talk about how it's working. So hit play, and I'm not going to touch the keyboard, and look at that. My ball is just kind of bouncing around, and it just keeps bouncing. Now I'm hitting the keyboard to move it around a little bit, and you can see that the cube actually moves with it too. So if I move, I get the ball bouncing and moving and the cube moving. I'm going to ignore the cube though and just control that ball. So why is this ball so bouncy and wiggly, and how am I making this happen? It's actually a side effect of this Sphere Collider's material. So a lot of time people don't notice this, but the colliders actually have a material option. If I go to my box collider, I could set it here as well. And we can just add in a physics material, and it'll adjust the way that the object responds to physics and collisions. If I select my bouncy one, you can see that I have my bounciness set to 1, which is the maximum. 0 to 1 is 0% to 100% essentially. And I've turned down the frictions all the way to 0. I also set friction combined to average, so that if it bounces and combines with something else that has little friction, it'll average the two out. And bounce combined to maximum, so it'll always be the maximum bounciness. That's a way to allow you to have multiple physics surfaces combine and do what they should do. Here I just really want it to be super bouncy. Now how do we create one of those? We just right click in the project view, go to create, and choose physics material. Where's that at? Right there. Choose physics material. You can name it, create your own, give it your own settings, and play with them as much as you want. Add them to the two objects that are bouncing and colliding. Try it out and play around. It's a lot of fun, and it gives you some really interesting gameplay options. Now let's take a look at controlling a character. Here we've set up a capsule for our character. So we just create a capsule with GameObject, 3D object, and capsule. I've added a rigid body and frozen the rotations. And then we have the jump script that we've used previously. That just adds force in the upward direction, and the rotate with mouse that reads our mouse X and then spins our transform rotation. So let's take a look at this. We can move, we can jump, we can kind of bounce into things, or bump into things at least. I can't really walk up those steps, but I can kind of jump up here. Let's see what the script looks like, what this code looks like, and how it works. Here we have another move with force use transform rotation script, but it also has a clamp velocity feature on it. And if you look at line 14, we're just checking to see if our velocity for our rigid body has approached or gone above our maximum velocity, and if it has, we just stop adding force. So this is kind of a soft cap where we're going to get to around 10. We'll go maybe a little bit over, stay kind of right around that level. We won't hard cap at exactly 10 though and stay there, but it stops us from going too fast. In our previous one, if we don't have this, eventually our cube or our character can just keep building up velocity and speed and get out of control. So here we have a way to control it and make it a little bit more like a player movement. So that's why when I hold down W, it doesn't ever actually just take off and get faster and faster and faster to the point where I'm going out of control. One question I get all the time is, should I use a character controller or a rigid body? What's the difference? Why do they both exist? Well, a character controller is really just kind of an extension of a rigid body. It does a lot of the things a rigid body does, and then a couple more things that characters generally want to do, like being able to walk up slopes and control gravity a little bit more individually, or give some extra, I guess, tight control over an object without scripting too much of it. More character level controls. So let's see what a character controller setup looks like. Here I've created a capsule and added a character controller to it. I've added my rotate with mouse script that just reads that X movement and spins us around. And then I have a character simple move script. I'm going to expand it out and show that it has a move speed and it is grounded. That isn't an option we check. This is just to kind of show what it's doing. So I'm going to hit play. We'll take a look at how this moves and then talk about it. So I turn, I run around, and you can see I kind of slide along that a little bit smoothly. It's a bit smoother than my default physics rigid body setup that I had. So when I had a character that was moving with a rigid body, it doesn't get that same smooth sliding. I also can just kind of walk up these slopes. Look at that. I can get up there and kind of run up there. It's a little bit small, but I can get up there at least. And if I had my jump, I'd be able to jump up there as well. And I move over here and just fall down. Let's take a look at the character controller settings now. So we have a slope limit that adjusts how tight of a ramp we can walk up. We have a step offset, which adjusts how big of a step I can take. So I can go up to here. I can't make that last step, but if I turn up my step offset a little bit more, there we go. Now I can step up there. And if I turn it up even higher, like to a 1, not 11, like a 1, I can even step up onto this block here. So slope is again for the incline. If I wanted to just crank it up and be able to walk up something that's more than 45 degrees, I could turn that up. And the step is for going up those actual stairs. The radius and height you can see in here. So if I go select my character and just start adjusting my radius of the character controller, you can see it moves, and that's what it's using for the physics to control the character. It doesn't use the actual capsule collider. And then the height. So if I crank this up, you see my character is much taller. Sometimes our radius and capsules, or radius and height, don't necessarily match our character exactly. We want to get them as close as possible, but sometimes we need to do some weird stuff. Like you may even have a character controller that's down low and a thing that's kind of flying above, like a hovering bird, where the character controller part that's moving around is controlled down lower, or the whole body or something. So let's take a look at this code. We have our character simple move script. Character simple move caches our character controller in awake, and then it has this public bool is grounded that again is just so that we can see it in the editor, and we'll talk about that after we look at this code. Then we have a fixed update method, and the fixed update, we read the horizontal and vertical axes into these two floating values. These are actually set up in edit and then project settings and input. So here's the input manager, and I've expanded out horizontal, and you can see that the left and right, or A and D keys, control the horizontal, and if I expand out vertical, it's down and up, or S and W. There's also another horizontal and vertical down here, by the way, and if you look at this, the difference here is that this is set to joystick axis. So this is actually going to read from game pads or controllers, where this one is going to read from key or mouse. And it can be a little bit confusing because you can kind of set up keys and button names that don't really map to things, right? So you might think that if you didn't have this one, it would still work. It won't. You need to have both of these in here if you want to be able to read from the keyboard and the controller. They're actually separate. That's why there are duplicates. It's intentional, but a little bit confusing. I understand that. All right, so let's go back into our code. We read those two floating point values that are either going to be 0 or a value between -1 and +1. So it'll be positive if I go up or right, and negative if I go down or left on my controller. And then we give a new direction, or we create a new direction, a vector3 named direction, by passing in the horizontal for the X and the vertical for the Z. We create a movement vector, and we do that calling the transform.transform direction. And this is kind of where that magic comes in, that's making it map to world space or local space, where it actually controls our character and we can have the camera snapped behind him instead of moving around in world space. So instead of using like a world transform, we're creating this local transform here. And that's all this is. This movement transform direction just takes a world position like forward and converts it to my local forward. And multiply that by move speed, and then we call character controller.simpleMove. I'm going to add a space here. Character controller.simpleMove returns back whether or not the character is grounded, which means whether or not the character is on the ground. So we call simplemove, we give it our movement amount that we want to move, and we just get back whether or not it's on the ground. We're not doing anything with that. We're just kind of putting it into the editor because I wanted to show that we can read that and we can use it if we need to. So let's take a look at it. I'm going to go in here, I'm going to go back to my game view, and I've got my character selected, and I just want you to look at the is grounded part. So let's change the height back here to 1, or what was it, 1.8. There we go. Now watch the is grounded value. If I go up here, I'm still grounded. You can see there's a little bit of a period where it drops, and if I drop off the edge, a little spot where I'm not on the ground. And we can use this to control things like jumping on a player. So if we want to have a player that jumps, then we don't want them necessarily jumping when they're not grounded. If we have a character controller set up, we can just read that and tell whether or not they're on the ground. In fact, let's go do that now. Here I've set up a character with the rotate with mouse script and my character move script so that I can turn, rotate, and do this nice little jump action. So I can jump up on these cubes, bounce around like a weirdo, and have some fun. I also wanted to note though that the main camera is just a child of this object, and that's how it's following it around. So if I go to the main camera, hit F, you see that it's just a child with an offset here kind of aimed down there. So as I move my thing around, it just kind of follows me nice and tightly. So I can jump. Now let's go take a look at the character move script. Well, first let's note that we have a move speed, a jump speed, and a gravity. something that we haven't had in previous scripts. I'm going to open this up and take a peek at it. We have an awake that caches our character controller, and then we have a move direction that we're keeping up here, this vector 3. I'm going to get rid of the private keyword because it's a little bit of extra noise we don't need there. So we have this move direction, and then we have a fixed update. Our fixed update reads our horizontal and vertical axes. We get an input direction vector that we create from our horizontal and vertical, giving them to the X and the Z. We transform that into our local objects transform, so our forward will be forward for our object. And then we take that transform direction and we're putting it into this vector 3 called flat movement. And you'll see why in just a moment. That is the move speed times our time.delta time for our fixed update, because in a move call, which is not going to be the same as the simple move call, we actually need to take into account time and delta time. The move call, or the simple move call that we have here, we don't need to pass in that delta time. It's going to be kind of automatically figured out for us. We also can't pass in a Y value. We can't go up and down with simple move. Move is going to allow us to do all of that, but it also makes us put in the extra work of handling that stuff. So we're taking our transform direction, multiplying it by delta time and our move speed, and that gives us our move direction. But our move direction isn't exactly the flat movement. It's the flat movement's X and Z values and the current move direction's Y value. So we're keeping this vector around every frame, and the Y value is being controlled completely independent of our input. So our input for horizontal and vertical are only controlling the Z and the X, and the Y is controlled some other way. In fact, you'll see how it's controlled 2 lines down. So how do we control it? Well, we check here on line 25. If the player jumped, then move direction.y is set to our jump speed, which I think I've set to 0.5. Else, so if they didn't jump this frame and they're grounded, then we just set their move direction to 0. So if the character controller is on the ground, move direction 0, we don't need to push them down at all. And now is grounded is also a check on the character controller. So I'd mentioned that we can use the simple moves return value to see if it's grounded. We can also just read the is grounded property on the character controller at any time to see if it's on the ground. And then the final thing we do if we're not jumping and we're not grounded is apply some gravity by subtracting gravity times delta time from our move direction. So we just keep applying gravity every frame. This value gets lower and lower and we fall faster and faster. And then we finalize it with character controller.move and pass in that move direction to make our character actually do the movement. The final thing I want to take a quick peek at is our player jumped, which just checks to see if the character is grounded and they pressed space. So this little check right here makes sure that they are already grounded. We can't jump if we're not grounded. And that's how it works. Gives us a nice simple character controller that we can move and bounce around and play with the values of a bit. Navigation is another type of movement that we use a lot in video games, where we want a character to kind of figure out its own way to a position. We don't want to necessarily script that it moves from point A to point B to point C and then figure out all of the code to move it to a specific character or any of that stuff. Instead, we can use the built-in navigation system to do a lot of that work for us, and you'll be amazed at just how easy it is to do. So here I've got a navigation set up just to show kind of what it looks like, and I'm going to hop into game view, click around, and watch my character move. So I click and the character moves to wherever I click, if he can get there. He gets at least as close as he can to it. And the camera is just stuck behind him, so it just kind of moves. I'm going to click right up there and watch as he just kind of finds his way up the ramp. So how does this all work? How do you set it up? Well, there are a couple of things that are important to note here. First, let's take a look at the character. Our character is set up with a capsule, just like every other character we've made, where we go to GameObject and choose 3D Object and create a capsule. But then I've added a NavMeshAgent component that's already built in, and a NavMesh character script. I have not changed any of the defaults on the NavMeshAgent script, and we just have this character. But I've done a little bit more to the scene, and this is the really important part. If we go select the environment here, which is actually all of our objects, I'm going to go to the scene view, go to environment and just turn it off and on. It's everything except for the camera and the character. Notice that the static checkbox is checked. If I drag this over and expand it out, the really important one here is navigation static. I can actually uncheck this and hit yes, change children. and just check the navigation static and hit yes, change children again, which is going to make it apply to all of these children down here under the environment. So if I just have that, it's enough to allow me to do my navigation, but not alone. I still have to do more. I still have to get to this navigation window and tell it to do a bake. Now, if you don't have the navigation tab open, you have to find it through Window, and it's currently under AI and navigation. It may move, it seems to move a lot, so just be ready for that. Now, when I've gotten this window open, and by default it's on the object option, it's just showing me the environment. There's really nothing here, but if I select the ground, you see that it has the navigation static checkbox here. So this is another spot where I can set that. I can go through and click on each one of these and set the navigation static option. I can also set whether they're walkable, not walkable, or if they're like a jump area. Now, I've got all of mine set to walkable because I want to be able to walk on all of them. And I need to go to the Bake tab. I've already done this, and that's why this is blue, but by default, it's going to look like this. You're going to go in, and it looks like this, and you go, oh, well, I don't have my blue part. Maybe you don't even have this on, and you go hit Bake, and you go, oh, I still don't have my blue part on. So what you need to do is make sure that you've hit Bake and that you have Show Nav Mesh checked. Then it'll show up. If I hit clear, it should wipe it out, hit bake, and it should reappear. Now it's really fast because my map is tiny and the computer's fast. The speed may vary if you try to do this on a giant world map, but on something reasonable, it should be almost instant or really, really fast. There are also some options here that you can adjust for the radius of how big a character has to be for when it's doing this generation, and how big it thinks the character should be, and how far they can jump, how far they can drop down. A little bit more advanced stuff that we're not going to dive into today, but those are the two important things. There's also an areas option where we can set costs of areas so that they'll prefer lighter areas or easier to walk areas like roads over swamps, for example. And then there's some option for controlling agents and making different types of agents that have different settings. Again, we won't dive too deep into that. I just want to get at the character and see how it all works. So we have the NavMeshAgent and we have this one script. Let's see just how much code I had to write to make it happen. Oh, that's it. So we have our NavMeshAgent in awake being cached. And then in our update, we check to see if the mouse button 0 was pushed down. So if I left clicked, mouse button 0 is the left click button and down is the event when I fire or when I first click it. And if so, we create a ray. A ray is just a invisible imaginary line into the world. And we're doing it from the camera using our screen point to ray and giving it the input.mouse position. So what this is going to do is create an invisible ray into the world from wherever we've clicked. And it's going to go intersect with whatever object we've clicked on, essentially. Then we'll get a Boolean back when we call our physics.raycast, and we pass in array. Now there are a lot of ways to call a raycast. This is just one of the many, or one of the easier of the many ways. You can also pass in a bunch of parameters. I like to do it this way though. Create the ray, pass that in, and then we take an output parameter of hit info. Now I'm assigning this to a bool. We could also have this inside the if statement, but I want to make it very easy to read. So we check to see if we hit something. So if the raycast actually intersected with something, so we actually clicked on an object that had a collider, then we figure out where we clicked, which is that hitInfo.point. It's actually part of this. We're not really figuring it out so much as putting it into a named object or a named vector. And then we tell our NavMeshAgent to set the destination. And this is it. This is all of the work that we're really doing. The majority of everything else is just figuring out where we've clicked, and then we just say, hey, go to this point. So if we have a thing or a place that we want it to go to, all we have to do is call set destination and it will go there. If we want it to move to another object's position, we just give it the object's position and it will try to move there. That's all there is to it. Navigation is relatively simple for the majority of stuff. There's also a project on GitHub for the newer navigation stuff. I would look into that. It may or may not be into the package manager when this comes out or when you watch this video. It's kind of constantly changing, but the navigation system is just getting better and better and more powerful. You can do navigation systems where they walk on ceilings, walk on walls, do all kinds of fun, cool, and interesting stuff. So it's a neat way to move things around, and it's really, really accessible and easy to use. Now let's look at animation as a way to move objects. A lot of people overlook this as a possibility, but it's a really common way to move objects when we have a set pattern or set movement that we want to do, and we want to be able to have some tight control without having to write a lot of code and having to manage that. We want to be able to maybe easily change it. So here I've set up my character controller character scene, but with an animating box in it. And I'm going to go to the inspector tab and take a peek at it. We have on here an animator that has this animator controller called animating box. If I open it up, just double click on it, it has a box moving script with a motion called box moving. Seems like a lot. I really didn't create all of this. It's all kind of automatic, but I want to show you what it looks like and how it all works. So then we go into the box moving, and if I double click on it, I actually get the animation window, which is different from the animator window. Animations are the individual independent animations of objects or sets of objects. Animations are a state machine, or sorry, animators are the state machine controller that allow us to switch between different animations. The animator controls the animations. Okay, so if we jump to the scene view and I select my animating box and I look at this animation window, suddenly I can see my animation here. And if I hit the play button, I can see that I actually have an animation where my cube moves back and forth. I'm gonna hit play, run into this cube, see what happens real quick, and then talk about how you can create these animations, modify them, and just show you how easy it is to do. So I'll hit play. And we're in game view mode, and look at that. Oh, the box actually knocks me around. Now, one thing I can't do is jump on it and have it slide me back and forth. I've actually done a video on exactly how you can accomplish this and a couple different ways that you can accomplish this. So if you're interested in that, just go look through my videos for sticking to objects and you'll see it there. Otherwise, let's dive into how this actually is created and how we create our own animation. So I want you to note there's no code here. I didn't write any code. This is all just an animation that I've created. So I'm going to delete my animating box and I'm going to go through the steps to create it again. Deleting that, and I'll go into my project. I'm going to delete the box moving here, and I'll delete the animating box .controller. So I just have my scene here. Now I'll create a new cube. Go to 3D object, cube. I'll reset the position. And I'm going to move it over to where I want. So here I'm holding right mouse and using A to go over, and I'll hold control and just kind of snap this up to somewhere I want. Let's go somewhere a little bit different. Let's maybe go up and down instead of left and right. That might be a little bit more interesting. Probably not, but we'll see. Okay, so I've got my cube. I'm going to rename it to animating cube. And then we'll go to the animation window. And here I just hit the create button. I need to have the cube selected, but if I hit the create button, it's going to give me a pop-up. And I'm going to be in the right folder already, this animation one, but I'll call it cube up down. Give it a name, and it gives me a .anim file. If I look in here, cube up down's there. I'm going to go back to the animation tab though and hit record. Here I can just take this and move the position just a little bit, and it'll add a keyframe for the position. Now I can drag this little timeline over here and let's go to the halfway mark at the 0:30. Drag this down to the ground. In fact, you know what? Let's use Control Shift and use that neat little snap to ground. And then I'll go over to the 1.0 area again and drag it back up. In fact, you know what I'm going to do? I'm going to delete that, select it, and hit delete. I'm going to select this little keyframe and hit Control C to copy it. Click over here to 1 and hit Control V to paste it. So that way I've got this nice smooth down and right back up to its original position. If I hit play, I can watch it kind of in action. And if I hit play in game, I should be able to see it kind of pushing up and down, stomping. Now it's going to act a little bit weird on me and just kind of knock me out of the way because that's just how it works. It's not a very smooth surface and my head just kind of gets knocked over. But you get the idea of how we can move these things around. I want to show you that we don't just have to do position though. I could also have it come to here and at this point maybe hit the E or R and go to the scale tool and make it wider. So maybe it goes down and gets huge. And then it goes back up and gets small again. So I've added this keyframe and it actually added it for all of them because I didn't hit the record button. So I'm gonna hit undo, redo with Control Y. Then I hit the record button, go to this point and go back to that scale tool and drag this out and then drag this out. And now if I drag up and down, you see that it shrinks and then stretches. And it doesn't shrink back down though. So I can just copy this frame again here, go click on it, Control C, click over here, Control V and paste it. Now I've got this like going down and splattering. In fact, I'm gonna make the splatter even bigger. Let's make this like a 4 and a 4. So it goes down, shrinks, or goes down, flattens out, and then gets big. Look at that. Neat little movement, and it would still kind of Look at that, lift our player up. There's something strange, not a great look, but I think you can get the idea of the cool stuff that we can do with animation and how we can even animate these physics objects and have them interact with the world. All right, if you made it to the end here, please just drop a comment and let me know if it was useful or not useful or helpful, or if you got confused, or if you had any questions, drop those down below too, or suggestions. It really does help a lot, even more than just hitting the like button. If you can't leave a comment though, the like button is helpful as well. And I also wanted to say a special thanks to everybody on Patreon. You guys are awesome. I really appreciate the support of you and everybody on this YouTube channel. It's great doing this stuff. I have a blast with it, and I hope that you're learning a lot too. All right, thanks again, and goodbye.